Okay, this is the first video for the Year 10 Autumn Assessment, and the very first section is about vectors and scalars. So we've got here a question asking what's a vector quantity, and we know that a scalar only has a size. Oh, come on, pen. Only has a size. Now, the posh word for that is we say it has a magnitude. Now, ultimately, that just means it has a number, it has a value, that's it. But a vector, we've been showing that it needs to have a size and a direction. So what's a vector quantity? It's a quantity with a magnitude or a size and a direction. So then we've got some measurements here, and you've got to say whether they're vector, they just have a size, a scalar, it has just a size, or a vector, it has a size and a direction. So speed is a scalar, acceleration is a vector, force is a vector. We spent ages remembering that weight is a force, and we can include a direction for that. Mass is a scalar, velocity is speed with a direction, so that's a vector. Distance is a scalar, and displacement, which we use the letter x in meters. We've looked at this, and I'll just put it on the side over here. We said, well, if I walk here and then I walk there, the displacement is the shortest distance with a direction between the start and the end. And you've learned how to, there's side A, we're after C, and we've learned that C equals the square root of A squared plus B squared to get that size. Or you could draw a free body diagram or a vector diagram and just measure that line using a scale. So displacement is a vector quantity. So we've now got draw a force arrow to show the force of the exhaust gases on the rocket. So this is obeying Newton's third law of motion, which is for every action there is an equal and opposite reaction, A equals minus R. So the crucial part to this is you've got to make sure that the arrow that you draw is the same size. So whatever the gas is coming out and the force from that, it is the same. So I'm going to try and draw this the same thickness and the same size, but I'm drawing it freehand. And there we go. Now what I'd do is I'd use a ruler to measure that and a ruler to measure that and make sure that's right. Next part, it says explain why rocket propulsion is an example of interaction force pair. So we've said an interaction force pair is, I'll change my colour for this one, two forces between two objects that are equal in magnitude and opposite in direction. And we have to state what they are. I think Holly in lesson used the idea of gases and propulsion. I'm happy with that. I'm just going to use the idea of, well, I've got gases providing a force that way, and then I've got the rocket going that way. So why is it an example of an interaction force pair? And that's because the force, so I'm starting with the 2F, of the gas on the rocket is equal in magnitude and opposite in direction. So we've got that bit and that bit in there is equal in magnitude and opposite direction to the force, and then we just swap those two round to the force of the rocket on the gases. If I just change my colour there, let's get a little bit of that's quite a pretty colour, I'll go with that. So we can see I've got force mentioned there and force mentioned there, 2F, the two objects, gases and rockets, and we've got to remember in the second statement we flip those round. So the force of the gases on the rocket there is equal to the force of the rocket on the gases, and then we've got equal in magnitude and opposite in direction. That's your model answer for that one. Next part, you're all fabulous at these in lessons, so I'm going quite quick on this one. It's we've looked at the formula triangle of my wrinkly gran, and you know that on Earth gravity is, and I'll put the unit, so I'll just tidy that up, apologies, is 10 newtons per kilogram, or 10 meters per second squared. And then we're ready. So it says, what's the mass? So I want that, and I can say I've got W on top, G underneath. So M equals W divided by G. That's going to equal 1.4 divided by 10 equals 0.14. And then I need the unit, kilograms for mass. So if I find out where my marks are for there, let's get my green pen for marking. Formula, number, unit. On to the next bit. I'm loving this, using loads of different colours. It says the rocket stops and then it falls. So clearly falls, this is about gravity. And I've got to make the assumption that this is on Earth. So it says, what's the acceleration? And you can see it's a one marker. So you don't have to do any complicated calculations on it. And it's what's the acceleration? And we just need to know that objects accelerate at 10 meters per second squared downwards when they're falling. Next one. I'll use that little purpley colour there. It says a piece of paper's got a mass of 0.02 kilograms. Great, no unit change. And what's the weight? So I've got mass, weight. Doesn't tell me gravity, so I've got to assume it's Earth. So my wrinkly gran. Oh my God, the wrinkly bit's a bit rough. There we go, that's a bit better. What's the weight? So I've got to find that. I'm going to see that's M times G. So W equals M times G. W equals 0.002 times 10. Or whatever value. If they tell you in an exam the value is 9.81, you use what they tell you to use. If it's not, that the value is not there, use 10. So this is going to equal 0.02. And then weight. Weight is a force, newtons. And it'll be towards the centre of whatever object it's placed on. Marks 1, 2, 3. And we've got the last little parts on this. Tying it all up. Let's change to that pretty blue there. It says a runner travels 950 metres. Beautiful. Don't need to change it. 45 seconds. Beautiful. Don't need to change it. What's their speed? So I've got a distance. I've got a time. And it wants the speed. So shoot. Donald Trump. Definitely going to think of a new one for that, given the most recent escapades in America. So I'm going to have to think of a different one for that. S equals D over T. I want to find S. That's going to equal 950 divided by 45. And I think in class, and I'm going off the top of my head now, 22.1 meters per second. Mark, mark, mark. And this one, it's always on the exam, so make sure you're good at it. What is velocity? It's speed with a direction. So there's the first part on vectors, scalars, mixing those all together, and various calculations. So we've got weight, which is a vector. We've got speed, which is a scalar, and we've got velocity, which is a vector. So I hope that helps.